What this whole system is leading towards, folks, is complete digital control of everybody and a merging of human beings with AI. And when you look at Elon Musk and some of the stuff he's been putting out, he's saying that it is necessary for us to merge with AI. It's going to be the only way to save us against AI completely taking over. And he's saying this needs to be done through a neural net. And listen to this.
So I think if we can effectively merge with AI by improving that the neural link between your cortex and your digital extension of yourself, which already, like I said, already exists, just has a bandwidth issue, and then effectively you become an AI human symbiote, and if that then is widespread with anyone who wants it can have it, then we solve the control problem as well. We don't have to worry about some sort of evil dictator AI, because kind of we are the AI collectively. It already exists, just has a bandwidth issue.
Pay close attention to what he said there. What he said was that this interface already exists. It's just that they have to improve the bandwidth. They have bandwidth problems. So how might these bandwidth problems be improved?
Starlink is a form of space-based internet service. The aim of the service will be cheap global internet coverage with 5G service without need for extensive infrastructure or expensive contracts to keep customers locked in for years.
Phase 1 of the Starlink constellation consists of 1,600 satellites arranged into 32 orbital planes with 50 satellites in each plane.
To create a comprehensive global communication system that provides high bandwidth, low latency connectivity anywhere in the world, and provides cross-links through the satellites so that you can have improved long-distance internet. You can actually have a more direct path through space, and photons move faster. And depending upon what fiber optic material they're running through, photons actually move about 40 to 50% faster in vacuum than they do in fiber optic cables.
It's likely that we will merge somehow or another with this sort of technology and it'll augment what we are now, or do you think it will replace us?
From a long-term existential standpoint, that's like the purpose of Neuralink, is to create a high bandwidth interface to the brain such that we can be symbiotic with AI. Because we have a bandwidth problem. You just can't communicate through your fingers, it's too slow.
And where's Neuralink at right now?
I think we'll have something interesting to announce in a few months. That's at least an order of magnitude better than anything else. Probably, I think better than probably anyone thinks is possible.
How much can you talk about that right now?
I don't want to jump the gun on that.
Speed of light in vacuum is somewhere 40 to 50% faster than in fiber. So you can actually do long distance communication faster if you route it through vacuum than you can if you route it through fiber. If, let's say you want to communicate from Seattle to South Africa, if you look at the actual path that it takes, it's extremely convoluted. It'll follow the outline of the continents. It'll go through 200 routers and repeaters, and the latency is extremely bad. Whereas if you did it with a satellite network, you could actually do it in 2 or 3 hops. Let's say at least an order of magnitude fewer repeaters or routers, and then going through space at 50% faster speed of light.
You're currently in a symbiotic relationship. Your cortex and limbic system are in a symbiotic relationship. And generally people like their cortex and they like their limbic system. I haven't met anyone who wants to delete their limbic system or delete their cortex. Everybody seems to like both. And the cortex is mostly in service to the limbic system. People may think that the thinking part of themselves is in charge, but it's mostly their limbic system that's in charge. And the cortex is trying to make the limbic system happy. That's what most of that computing power is oriented towards. How can I make the limbic system happy? That's what it's trying to do. Now, if we can have a third layer, which is the AI extension of yourself,
that is also symbiotic. And there's enough bandwidth between the cortex and the AI extension of yourself such that the AI doesn't de facto separate, then that could be a problem.
So the focus is going to be on creating a global communication system. This is quite an ambitious effort. So we're really talking about something which is, it's in the long term, it would be like rebuilding the internet in space. And the goal will be to have a majority of long-distance internet traffic go over this network, and about 10% of local consumer and business traffic.
It's just that the data rate, the rate at which, or the communication rate between you and the cybernetic extension of yourself is slow. It's very slow. And that is like a tiny straw of information flow between your biological self and your digital self. And we need to make that tiny straw like a giant river. Huge, high bandwidth interface. It's an interface problem. Data rate problem. If you solve the data rate problem, then I think we can hang on to human-machine symbiosis through the long term.
So I think it's something that definitely needs to be done, and it's a really difficult technical problem to solve. And at the same time, we also make sure we don't create Skynet. Ironically, the server room at SpaceX jokingly was called Skynet. If there's some AI apocalypse, it's going to come from some collection of sort of vast server farms, terrestrially based, not via the space-based communication system. I did think about that. Anyway, so I think this is sort of like a fundamentally good thing to do. Properly designed to give people gigabit level access, kind of 20, 30 millisecond latency everywhere on Earth. That would be pretty great. And then that same system we could leverage to put it into a constellation on Mars, because Mars is going to need a global communication system too. And there's no fiber optics or wires or anything on Mars. So we're definitely going to need that. We're going to need high bandwidth communications between Earth and Mars. So I think a lot of what we do in developing an Earth-based communication system can be leveraged for Mars as well.
Well, most people don't realize they are already a cyborg.
The satellites we have in mind will be quite sophisticated, and there'd be sort of a smallish satellite, but with a big satellite's capability. By smallish, I mean in the few 100 kilogram range. Well, it can't be free, because then we'll go out of business. I mean, this would cost a lot to build. I mean, ultimately, over time, to build a full version of the system, we're talking about something that would, be $10 or $15 billion to create, maybe more. And this is intended to generate a significant amount of revenue and help fund a city on Mars. So this is, in looking in the long term and say what's needed to create a city on Mars. Well, one thing's for sure, a lot of money. So we need things that will generate a lot of money. Spectrum that is omnidirectional and wall penetrating, that spectrum is extremely rare and limited. Spectrum that is not wall penetrating and that is very directional is not rare. It's sort of the difference between kind of a laser beam and a floodlight. You can have like lots of laser beams, in the limit that would be sort of a real type beam communication. There's high scarcity for cellular bandwidth. There is not high scarcity for space to Earth bandwidth. Iridium satellites, which was a sort of a mere 70, we're talking, more than order of magnitude larger volume. I mean, there may be some similarities to the way that the Iridium network was done, but in terms of the production, the way it's produced, it's going to be closer to the way that a car is produced or consumer electronics. So we take things even a step further, and if the satellite didn't work, you just basically take it out of the constellation and deorbit it. An analogy might be between, say, mainframes and PCs. So if you want to have a big data center serving, millions of people, it's way better to have an array of cheap PCs than it is to have a few mainframes. And that's basically how all of the internet is served is with millions of PCs on racks instead of mainframes. The main propulsion system we're to have in mind for the satellite is a Hall effect thruster, which, not to trivialize it too much, is basically like a loudspeaker. Okay, it's like a magnetic field. I think it's important to assume that terrestrial networks will get much better over time. One of the mistakes that, say, Talvizik made was not assuming that terrestrial networks will get much better over time. So we need to make sure that the system we design is good, even taking into account significant improvements in the terrestrial systems. I do think there are some important differences between what we're doing and say, Talvizik. In the case of Talvizik, they were trying to talk to phones. And then that gets back to that problem of a roof-penetrating situation. And it's particularly difficult when stuff is coming from space. Like if you're in a skyscraper, it's got to go through 27 floors to reach you. That's not going to happen. There's nothing that will, short of like a neutrino. You can have like a neutrino phone. Yeah, I think we're going to have to pay a lot of attention to security. It would really be unfortunate if it got hacked and taken over. But it's going to require a lot of thought to make sure we are able to protect it from any hacking.
5G, first and foremost, is densification. So it's significantly more transmitters at close proximity to a human, and it is also a sophisticated, illegal, unlawful transmitter. What I mean by that is it is a high gain dielectric lens antenna, and what that allows 5G transmitters to do is to 3D map its environment in your home. The 868 megahertz frequency is specific for battlefield interrogation systems, so sub-gigahertz. It allows the signal to travel through concrete brickwork with ease, and it can actually data gather. It is a target acquiring system. Phased array is basically radar off the battlefield. It is extremely good at identifying targets and being able to lock onto targets. And not only that, it can specifically target you as an individual. So any judge sitting on an interesting case, let's say, any lawyer, any barrister, anybody doing any work that is potentially controversial, your life could be at threat. So the antenna design that you currently have on top of these LED streetlights, masquerading as a control management system, is basically battlefield interrogation equipment. The first phased array unit was actually called Mammoth, used by the Germans during the Second World War to identify Allied aircraft. Obviously things have moved on significantly since then.
So for those that don't know anything about CERN, CERN are the people that are behind the Large Hadron Collider, or Hadron Collider, I know there are different pronunciations. This is a project that stems several countries, under France, under Switzerland, teamed up with the United States. Well, they literally just announced in the last several days that they are going to build a new superconductor. This is already 26 miles in length, okay? And this one will be at least 52 miles in length, but may be even larger, and they're saying it's going to take decades. Now, publicly, CERN is about basically recreating the Big Bang and finding the quote-unquote Higgs boson particle, the God particle. And I believe they've announced that they've found it 3 or 4 times, only to retract those statements again and again. The question is that what they're really doing? And if that's what they're doing, why is there so much money behind it? You would assume that they're trying to do something else, harness a different energy source, study something different. And to have the stage of some of the largest global political leaders here is very telling. Now, this is going to couple back on a micro level with some of the other people that are here. Eric Schmidt on the steering committee. He's the, one of the people on the board of Alphabet, the shell corporation for Google. Now, he's coming out of an AI conference out in China. Now, what's very, very interesting to me, and what a lot of people won't understand when I say this, is that Goldman Sachs has an even larger presence here this year. Why is that important? Well, Goldman Sachs are literally the lead investors with Jeff Bezos of Amazon and Dapple in the quantum computers that Google and NASA use in conjunction with one another, called D-Wave computers. Okay, and I know a lot of people aren't familiar with what D-Wave is. In fact, I wasn't very familiar with what D-Wave is or what a quantum computer itself is. Okay, in fact, it's very perplexing for somebody like us to even discuss these things. But in the appreciation of dexterity, Google and NASA put out a joint commercial where they promoted these D-Wave computers and quantum computers basically as a way to create better and better AI. But at the same time, they were promoting the multiverse theory, not as a theory, but as factual. And the best way I can describe that these things operate is that they are pulling matter out that is smaller than a quark, that's called a qubit. And a qubit, quantumly, can be represented as a 0 and a 1 at the same time, but then also creates even more of a masking qubit in between. And what they're saying is happening is that they're pulling out qubits, aka energy, from parallel dimension. I can't factually state anything. I can only tell you what they've talked about. But that's exactly what they're saying. They're discussing this as parallel realities in which everything is almost the same except for the position of 1 or 2 qubits that they're pulling through at a time. And the other thing that's super interesting about this is that this technology is on an exponential Kurzweilian singularity growth, where only 10 years ago they thought what was possible today wasn't going to be possible for 100 years. Say that I don't know where they're pulling these qubits from. You know, they very much could not be accessing the quote-unquote multiverse. And again, I'm using their own terminology. But what I thought was extremely interesting about it is that they talked about it not only on a micro level, taking these qubits out, but that these universes exist on a macro level. So basically, they're trying to talk about organic life like you and me, that they're pulling this power out. So flip that from being somewhat frightening, just based on talking about it. Their AI has gotten so good that their predictions from 2013 and 2014 that these computers, these quantum computers, would outpace their engineers has now become public. They literally say that the end goal of these things is to create human-like machines with artificial intelligence, and the only way that they were going to be able to do this is through quantum physics and the fact that the AI they create will create better AI. And again, this isn't me saying it. I will, hopefully give you some links in the description so you can see the gentlemen that used to work for DARPA that now are part of this project and espousing these things. And once again, like I said, just a week ago, Google announced that their AI is outpacing their engineers in creating AI. So now you have Eric Schmidt in there coming off an AI conference. You have Goldman Sachs at a higher level than ever that is heavily invested in this D-Wave technology. And then you have a guy like Peter Thiel, who is the technology advisor to the President of the United States and on the steering committee here at Bilderberg in attendance. I would be hard-pressed to believe that some of the things that I just discussed are being talked about on a level that I can't even comprehend. And to pull CERN in, which is almost like a macro project of these quantum computers, is just more evidence that they're definitely discussing these things. And I would assume, we are in 2017. AI is a real thing. The future of AI affects all of us. And the power elite are going to try to get a grasp on that so that you and I will have it on a controlled level, if at all. Well, yeah, no, people should be out here discussing these things, and I think that's why one of the things on the agenda is, can globalization be slowed down? Obviously, the people inside here are not trying to slow down globalization, but they want to know, to people like you, to people like the independent press, to people who are out here just protesting, do they pose enough of a threat that their ultimate goals can be slowed down? And once again, Trump isn't the first populist to be voted into office. You have Corbyn. You have the people voting on Brexit. You do see a lot more people saying, you know what, let's localize things. Let's be concerned about our own people, and let's get away from this globalization. And obviously, that's at big odds with the majority